Welcome to the world of enhanced website security and user privacy. In a digital landscape filled with threats and vulnerability, we present our groundbreaking project. Control and Authentication aims to design and implement an access control and authentication system. Primary objectives: enhance website security, safeguard user privacy, mitigate unauthorized access attempts. Project focuses on implementing robust access control mechanisms and efficient authentication protocols. By incorporating industry best practices, the system aims to protect sensitive information and ensure secure access to online resources. Our system uses advanced encryption algorithms to protect your passwords, ensuring they remain secure. Key objective: strengthen website security through the implementation of access mechanisms, user roles and permissions. Safeguard user privacy by ensuring only authorized individuals can access personal accounts and sensitive data. Identify theft and fraud risks through secure authentication methods, such as password hashing and multi-factor authentication. Enhance the user experience by providing an intuitive user registration and login system. Promote industry best practices for access control and authentication. Let's talk about Formulate Mathematics application used in access control and authentication system. Set theory, Boolean algebra, probability theory, cryptography. We prioritize user privacy by implementing secure authentication methods, such as password hashing and multi-factor authentication. This ensures that only authorized individuals can access personal accounts and protects against identity theft and fraud. Let's talk about set theory application in this subject. User roles and permission can be represented as sets for easy assignment and modification. Access control lists can be represented and edited using sets to determine access rights. User groups and memberships can be managed using sets and set operations. User preference and filters can be represented and matched using set operation. Now we will talk about Boolean algebra application used in access control and authentication system. Boolean logic is used to define access control rules and create complex condition. Role-based access control can be defined using Boolean expression. Boolean expression are used in authentication condition and access control policies. Boolean operators are used for user queries and filtering data. Next is probability theory. Its application in access control and authentication. Risk assessment helps quantify and assess the likelihood of security risks. Password strength assessment is based on probability theory. Two-factor authentication effectiveness can be evaluated using probability analysis. Risk-based authentication uses probabilities to adjust authentication requirements. Let's talk about cryptography. Its application used in access control and authentication. Password hashing ensures secure storage and authentication of passwords. Encryption of stored data provides additional protection for sensitive user information. Public key infrastructure creates a trusted environment for authentication. Token-based authentication using cryptographic techniques like JWT for secure access to resources. Now we're taking an example of password hashing. Let's assume we have a password myhashpass and we want to hash it using modular arithmetic. For simplicity, we will consider the password as a string of ASCII characters. Now we take ASCII values of each characters of password, like ASCII value of capital M is 77. And ASCII values of Y is 121, as follows. Now we will perform modulo arithmetic operation to each numerical representation which we had calculated above. Let's choose a modulus value of 17. Apply the modulo operation to each numerical representation. At last we store these values in sequential order. So resulting hash values are 9, 2, 1, 10, 12, 13, 13. Let's see how to verify the password. When the user attempts to log in, the entered password myhashpass goes through the same process. The resulting hash values are compared with the stored hash values for the user. If the hash values match, the user is granted access, otherwise, access is denied. This is the simplified example to illustrate the concept of modular arithmetic in password hashing. In real-world scenario, hashing algorithms are much more complex and involve additional security measures to ensure the strength of the hashing mechanism. It's in another example. This is a real-world example of access control and authentication. We understand hashing algorithm. For example, we take crypt algorithm. We have plain text, my password. Generate a random salt. A salt is random value that adds additional randomness to the hashing process. Let's assume our salt is, like I have given. Combine the salt with the password, concatenate the salt value with the plain text password. Salted password is like I have written. Perform the hashing algorithm. Crypt involves multiple iteration of hashing, which is desirable to protect against brute force attacks. Hash the salted password using BSIPT. Apply the algorithm to the salted password, iteration it 12 times. When a user tries to log in, you can repeat the process with entered password, the stored hashed password, and the same salt value to check if they match. This way the original password remains secure, as even if an attacker gains access to the strong password, they won't be able to reverse engineer the plain password easily. Thank you for joining us on Enhance Website Security and User Privacy.